Okay, so we're looking at 3, 4, looking at example 2 today, and we're going to introduce what is a shortcut for long division. Um, so long division we learned yesterday, and like the name, it takes kind of a long time to do. And you still do need to know it, but there is a shortcut for specific problems. So synthetic division is the shortcut, but it only works when you have an x minus a factor. So meaning, what I mean by that is if the divisor, the part you're dividing by, has to be just x minus some number or x plus some number. If it was 2x plus 2 or 2x minus 3, then you still have to do long division. If it's x squared minus 3, then you still have to do long division. So it has to be just single x and then plus or minus a number, and then you can use synthetic division. And this you're going to find is really quick. Once you get it down, it takes like 5-10 seconds versus the long division takes like a minute. So it's definitely worth making sure you know how to do. It's not technically needed because long division does still work, but it's definitely worth knowing because it's certainly faster. So here's how it works. We're going to take this problem here, and we're going to divide it by x minus 3. So synthetic division is the process, and it basically is a shortcut for long division. Again, only works when you have x plus or minus some a value. All right, so it says to change from long division to synthetic division format, write only the zero of the divisor. So this is really key. The zero of this divisor. So what would make this be 0? Well, that'd be 3. So we would write 3. And then we put it in like a little kind of half box. And then right next to it, we're going to write the coefficients from the original problem, the dividend. So in this case, it's going to be 2, -7. Notice how there's no x term. If there's missing one, we have to fill it with a 0. So in this case, looking at it like in standard form, it's going to be 2, -7, 0, -4. It's kind of like a matrix in a way. How like in the matrix, we just write down the coefficients of our variables and things like that. So it's kind of like that as far as setup. But we're going to do this by hand, and it's actually pretty nice and quick. So that's step 1. You get that set up. If there was space, I'd keep going, but I think I'm going to move it on down here. So I'm just going to rewrite the same thing I just did there. So again, these are my coefficients from my dividend. That's the 0 of my divisor. So here's the move. It says bring down the first coefficient. So we just bring this down, and we're going to write it right here. Easy peasy. Multiply your 0 of your divisor, which is 3, by this first coefficient. So 3 times 2 is 6. We write that right here. And then we add it to this second coefficient. So now we add it right here. -7 plus 6 is -1. And what we actually just do is we keep repeating that move. It's like the repeated stuff we do in the long division. It's just quicker. So once again, we multiply here and here. So 3 times -1 is -3. And then we add it with the next term. So 0 plus -3 is -3. 3 times -3 is -9. Those add to be -13. And so here we go. So now we've done this. What does this mean? The last number you get out is always your remainder. So this problem had a remainder of -13. Cool. Going from right to left, you can count up with variables. So this would be the constant term, this would be the linear term, and this would be the quadratic term. So this would be 2x squared minus 1x minus 3, and then a remainder of -13. So we'd say plus -13 over that divisor that we used earlier. Sorry, I'm off the screen there a little bit. My bad. So again, remainder, constant term, x term, x squared term. If you have more, if there's another number here, it'd be an x cubed term, and then x to the 4th, and x to the 5th, so on and so forth. But you always want to read it right to left because you know this number is your remainder. So therefore, like in order, it'd be number x, x squared, x to the 3rd if there was one, so on and so forth. So that's how you then interpret your answer. So this would be our quotient. This is the answer to the problem. You're going to find you can get super fast at this. You'll be able to crank through this at a much better rate than you do with your long division. So that's the process. Let's go ahead and look at it a few more times. Okay, so this one, use synthetic division here. If you think you got it, go ahead and pause it and see if you can do it. If you want to see another one, here we go. So we always take the 0 of the divisor. So that's going to be 1. It's whatever value makes this equal 0. That's the first mistake people always make. If you put in -1 here, it's not going to work. So the 0 from your divisor. Coefficients, 3. Notice how there is no x squared term. So 0. -5 plus 10. Sorry. You don't have to put the plus sign there, but I need to because I made a negative on accident. Okay. All right. We always drop the first term down. And now we repeat our steps of multiply and add. So we multiply, and then we add. And then we multiply, and then we add. And then we multiply, and then we add. All right. Looking pretty good there. So that shows us that we did get a remainder in this case. So the last value we get is our remainder. That's going to be constant, linear, quadratic term. So our answer is going to be 3x squared plus 3x minus 2, remainder of 8 over that divisor, x minus 1. Okay, so that's it. That's the synthetic division process. If you really want to, you could do log division to check it. Absolutely nothing wrong with it. You could also do distributive property to check it. Those, I think, take a really long time to do, but they are both doable. Like what I mean by that is if you took this x minus 1 and you went through and you distribute it to each of these, it is going to work out, but it's actually not it's harder to do than the actual steps. So there are checks, but they're not the easiest thing to do. There is a check you can do, which is we're going to talk about something called the remainder theorem here. So this is relating P of A to the remainder of the division problem. So this confuses people a lot, but it's supposed to be a nice little shortcut. So here's the thing. It says we're going to explore how are these two things related. So when you take your function, you just substitute A into it versus when you do the synthetic division. How are these two things related? So let's just start off, and we're going to take this polynomial they give us, and we're going to divide it by this. So we're going to do the synthetic division again, so you get another kind of rep of it here. So by synthetic division, we use -5 because we always use the 0 of this divisor. And then we take our coefficients. So 1, 10, 29, 24. All right, so I'm going to go ahead and work that out. Drop my first number down. Multiply. Add. Multiply. Add. Multiply. And add. All right, so I get a remainder of 4. Cool. By this problem, I'd be able to write my answer. There's my constant term, my linear term, my quadratic. So I'd have x squared plus 5x plus 4. Remainder of 4 over x plus 5. So there's like the quotient to the problem. So again, just another practice of the synthetic division. But then this also says, well, how does this all relate to if I just did P of A? If I just evaluate the function at -5, how is that related, the same, different, whatever? So that means take this function and just substitute in this -5 number in. So let's get out of here. So if I just took -5 and I just substituted it into the problem. So I'm going to use parentheses and just substitute things in here. Use my calculator because it's going to be a lot quicker. Okay, so took the function that was given to us and just substituted -5 in for all the x's. And that gave me 4. So in other words, P of -5 is 4. And doesn't take any Sherlock Holmes skills to notice that this number and this number are the exact same. So this number and the remainder are identical. So what's our takeaway from this is that P of A is equivalent to the remainder. And this is actually a really great way to check these problems. So if you're ever worried about doing your synthetic division and maybe making an error within here, if you got your remainder, if you do just P of this number, you should get that same remainder. It's the easiest, most efficient way to check your answer in the end. It's got some other applications too, but that's what I mostly use it for, as I find that's a pretty useful thing. All right, at this point, you should be able to do one of these. So see if you can do the synthetic division here, and then do the P of -2 and see if you get the same thing, or F of -2 in this case. It's the F function, not the P function, but try and see if you can do it. And then I'll work it out and you can check your work. Okay, so I do have it worked out here. You can check my synthetic division with your synthetic division. But again, it's always your coefficients. So 1, 8, 12, and 5. Drop it down. And then you're going to repeat the step of multiply, add, multiply, add, multiply, add. And you get a 0 in here, which is fine. 0 is a number too. Don't think there's anything wrong with that. In terms of what does this answer look like, 5 is the remainder. There's no constant term. You get a 6x and a x squared. So x squared plus 6x plus your 5 over that divisor. That's your quotient. And then I did f of -2. I just did it in my calculator like I did before. So I took the function and put -2 in, and I got 5 out, just as my check to show you, yep, that did work out and give me the same thing. Pretty much verifies I didn't make any math errors in my synthetic division. All right, so that should be good for today. Pretty much every problem you're going to see today is doing synthetic division. You might see a couple little remainder theorem stuff. We're going to do more of that tomorrow too. But mainly just checking out that you can do this synthetic division skill.